Now I want to explain about the problem on parallel current carrying conductors. So the problem is two long straight parallel current carrying conductors separated by a 2 meters carrying currents I1 and I2 in same direction. The magnetic field intensity at the midpoint of conductor is 7.5 ampere turns per meters. If the force on each wire per unit length is 2.5 into 10 to the power of minus 4 newtons per meters, so determine the values of I1 and I2. So first given data, so at midpoint of current carrying conductors, the magnetic field intensity is 7.5 ampere turns per meters. So these two are current carrying conductors. First conductor current I1, second conductor current I2. So here given the current direction same direction, so we assume the current's direction upward direction, I1 upward direction, I2 upward direction. So next one, distance between the conductors equals to 2 meters, d equals to 2 meters. The midpoint magnetic field intensity equals to 7.5 ampere turns per meters. So assume this point is point O, midpoint of two conductors. So given at this point the magnetic field intensity equals to 7.5 ampere turns per meters. So next one, the force per unit length equals to 2.5 into 10 to the power of minus 4 newtons per meters. This one. So next find I1 and I2. So now we have to find these currents I1 and I2. So given at midpoint the magnetic field intensity value. So assume this is the midpoint and assume from conductor 1 to midpoint distance equals to R1 and conductor 2 to midpoint distance equals to R2. So total distance between the conductors equals to 2 meters. Up to midpoint distance value equals to 1 meter. It means, so first conductor to midpoint distance equals to R1 equals to 1 meter. Second conductor to midpoint distance equals to R2 equals to 1 meters. So D equals to R1 plus R2, it equals to 2 meters. So first to find the magnetic field intensity at origin with respect to first conductor. The magnetic field intensity at point O, that is at midpoint, so due to first current carrying conductor. So we know that the magnetic field intensity due to straight current carrying conductor H equals to I by 2 pi R. So here first H1, the magnetic field intensity due to first current carrying conductor H1, it equals to I1 by 2 pi R1. I1 first conductor current, R1 first current carrying conductor to midpoint distance. So it equals to I1 by 2 pi, R1 equals to 1, so I1 by 2 pi. So similarly find the magnetic field intensity at point O. So due to second current carrying conductor, it equals to H2. So H2 equals to I2 by 2 pi R2 formula. Here R2 equals to 1, so H2 equals to I2 by 2 pi. So given at midpoint the total magnetic field intensity equals to 7.5. So find the total magnetic field intensity. So here, so between the conductors, so find the magnetic field direction by applying right hand thumb rule. Here current direction upward direction, so apply right hand thumb rule. The magnetic field direction anti-clockwise direction. So first conductor magnetic field direction anti-clockwise direction, second conductor magnetic field direction anti-clockwise direction. So now see between the conductor, so between the conductor, so first conductor magnetic flux direction upward direction, second conductor magnetic flux direction downward direction. So it means at midpoint two magnetic fields are in opposite direction. So the resultant magnetic field intensity at midpoint equals to, so difference of two magnetic field intensities. So H equals to H1 minus H2. H1 equals to I1 by 2 pi, H2 equals to I2 by 2 pi. So H equals to I1 by 2 pi minus I2 by 2 pi. So it equals to 1 by 2 pi I1 minus I2. So 1 by 2 pi into I1 minus I2. So given at midpoint the magnetic field intensity equals to 7.5. So I1 minus I2 equals to 7.5 into 2 pi. So finally I1 minus I2 equals to 47.1. So let this is equation number 1. So next one, in problem given the force per unit length F by L. So F by L equals to 2.5 into 10 to the power of minus 4. So the force per unit length formula F by L equals to mu into I1 I2 by 2 pi d. So given F by L equals to 2.5 into 10 to the power of minus 4, it equals to mu into I1 into I2 by 2 pi d. So from this equation we can find I1 into I2. So I1 into I2 equals to 2500, equation number 2. So from equation 2 we can write I1 equals to 2500 by I2. So substitute I1 in equation 1. So equation 1, I1 minus I2 equals to 47.1. So 2500 by I2 minus I1 equals to 47.1 and I2 equals to 31.718 amperes. So now substitute I2 in this equation and find I1. So I1 equals to 78.819 amperes. So I1 value and I2 value. So next second problem. So two long straight parallel current carrying conductors separated by 2 meters carrying currents I1 and I2 in opposite direction. The magnetic field intensity at midpoint of conductor is 7.5 ampere turns per meters if the force on each wire per unit length is 2.5 into 10 to the power of minus 4 newtons per meters. Determine the values of I1 and I2. So the only difference between last problem and this problem is, in last problem current direction same direction, here current direction opposite direction. In same way solve this problem also. So here everything is same. So main difference is the resultant magnetic field intensity. So in this case current direction same direction. So between the conductors magnetic fields are opposite direction. So H equals to H1 minus H2. So here the current directions are opposite direction. So based on this direction, so find the magnetic field between the conductors and find the resultant magnetic field intensity. Finally find I1 and I2 values.